Internet, welcome back. Today we're going to go ahead and look at the Lesson 7.3 homework assignment, similar polygons and triangles. Here, number 2, we got JKLM is similar to TSRQ. List all the pairs of congruent angles and write a proportion that relates the corresponding sides. Okay, so this is going to help us with writing the corresponding angles, and corresponding angles of similar figures are congruent. So if I look at the statement here, notice that J is the first letter and T is also the first letter, so we can say that angle J is congruent to angle T, and then angle K is the second, S is the second. I can go ahead and say that those two things are congruent. And then we have angle L is congruent to angle R, and then angle M is congruent to Q. So angle M is congruent to angle Q. So these are my corresponding angles, and the corresponding angles, once again, are congruent for similar figures. And then we have to write a proportion that relates the corresponding sides. Okay, so notice that over here we don't have anything marked, so we know first of all that angle J is congruent to angle T, so angle J is congruent to angle T, then angle K is congruent, angle K is congruent to angle S, angle L is congruent to angle R, and then angle M is congruent to angle Q. So that is going to be helpful for writing our proportion here. And when we're writing the proportion of similar figures, we write them as ratios. See, so ratios equal ratios, and perhaps equal another ratio and equal another ratio. So let me go ahead and demonstrate what I mean about that. Notice that we have JK, 1 arc, 2 arcs. That should correspond with TS. So, yeah, that should correspond with TS. Yep, there we go. So JK corresponds with TS. So the first two letters should correspond with TS. And that's going to equal to, I gotta go ahead and find another one here, LK. So LK is the 3 and the 2, so 3 in the 2, or we can look at LK here. So LK, that's the second and the third letter, and should correspond with SR. So KL corresponds with SR. And then what else do we have here? So we did these two already, and then these two already. So we have, let's see, we have 4, 3, 4, 3. So we can say ML corresponds with QR, right? So ML corresponds with QR. That's those two sides that are corresponding. And then lastly we have, use a different color for this one, we have JM, which corresponds with TQ. So JM corresponds with TQ. Okay? And then you can go ahead and verify by just looking at the similarity statement already. Remember, when we're writing similarity statements, they have to be in order of correspondence, right? So angle J is congruent to angle T, K, S, L, R, M, Q, and then J, K, T, S, and so on and so forth. That should be it for that problem. And then we got this. It says determine whether each pair of figures is similar. If so, write the similarity statement and the scale ratio. So if the figures are similar to each other, your reason should be angle similarity, side similarity, or side angle similarity. And perhaps you might have a not possible. Okay, so if I were to look at 12, notice that, okay, we can say that angle K is congruent to angle Z, and, well, if I look at angle M, is that congruent to W or Y? No, so angle M is not congruent to angle W, and it's also not congruent to angle Y. So this is pretty straightforward because there are no congruent angles. In similar figures, they have to have congruent angles. So these two triangles are not similar at all. So no, these triangles are not similar. And I can stop right here because they're not similar. If they were similar, then I can go ahead and write my similarity statement in the scale ratio. Okay, hopefully that makes sense. Just to recap, so we know that angle K is congruent to angle Z. They're right angles, that's awesome. But we have to look at the other angles. Notice an angle M is 42. Is there a 42 here or here? No, because there's a 39 and a 51, so they're not congruent. The angles are not congruent, except, you know, the 90 degrees. So therefore, we can say that these figures are not similar, if that makes sense, okay? Let's go ahead and take a look at 14. So, let's go, the first thing that you should do is look at their angles and look at, actually, let's go ahead and look at their angles because I can see something. Notice that we have angle B, which is congruent to angle F, and then we have angle D is congruent to angle G. So if we have these two pair of angles that are congruent, then obviously with the third angles theorem, these angles are congruent, right? So are these two figures similar? If so, is it angle-angle similarity, side-side similarity, side-angle-side similar, or not possible? And I'll let you decide on that one. Alright, so for 18 and 20, each pair of polygons is similar. Find the value of x. All you have to do is create your equation or your proportion and then solve for the variable x. So you can see that here's a 1 arc, 2 arcs, 1 arc, 2 arcs. What am I supposed to do with this and this? And what should you equal that to? And then you're going to get x equals 7 for number 18. For 20, you're going to get x is equal to 2. So notice that I have one right angle, that's 8x minus 1. One right angle, that's 12. What are you going to do with these two expressions here? And what are you going to set that equal to? You're going to have a ratio equals a ratio. So you should get x equals 2 for number 20. 23, 27, find the perimeter of the given triangle, triangle DEF, if triangle ABC is similar to triangle DEF, where AB is 5, BC is 6, AC is 7, and DE is 3. So you're going to find the perimeter of triangle DEF. So what is the perimeter of this? If I were you, I would look at the notes for this one. And then number 27, two similar rectangles have a scale ratio of 2 to 4. The perimeter of the large rectangle is 80 meters. Find the perimeter of the smaller rectangle. So you have that scale factor already. And then, well, this is my scale factor. It's 2 to 4, which reduces to 1 to 2, or 1 divided by 2. So I do 1 divided by 2 equals, so if we just look at the numbers here, well, obviously which one's the smaller one? So we know that 2 is less than 4, so 2 is the smaller one. So this has to be the smaller rectangle to the bigger rectangle, or in this case it's the smaller to the bigger rectangle. Smaller to the bigger rectangle. So if you were to do 1/2 equals your ratio here, what should you put up top and what should you put in the bottom? Well, we only know, if I were to draw the figure. So here's my small rectangle, here's my big rectangle. Do we know what the perimeter of the small rectangle is? No, we don't, because that's what we're trying to find. So the smaller rectangle, we're going to let that be x, and the bigger rectangle, we're going to let that be 80, because it says that the perimeter of the large rectangle is 80 meters. So then again, you have your small to big, which what you should equal that to is the small perimeter to the big perimeter, and then you're going to cross multiply. So you're going to have a number here and a number here. You're going to cross multiply, and then you're going to go ahead and find your perimeter that way. So what is the perimeter of the smaller rectangle? That's your answer. And then finds the value of each variable. Okay, so these figures are similar because it says A, B, C, D is similar to Q, S, R, P. This is a similarity statement. You know which one corresponds with which. So if I were to say, if you know that angle D, because angle D has that X, right? So angle D corresponds with angle P. So angle D corresponds with angle P. So what are you going to do with these two expressions? And then you see that angle R over here has that Y that I'm looking for. So angle R is the third letter. So angle C is the third letter. So what are you going to do with these two expressions? Okay, that's my hint to you for that one. Number 57 in the figure, triangle ABC is similar to triangle DEF. What is the perimeter of triangle DEF? We know if I were to add these figures, or not the figure, sorry, if I were to add these sides up, that should give you the perimeter, right? So you're going to go ahead and calculate that. What's the perimeter of this? And then you're going to figure out what the perimeter of this is. Notice that all these sides are given here, but all the sides over here are not for the smaller triangle. So this is just the same idea as these two here. Okay, so you can go ahead and figure out number 57 on your own. Alright. Here I'm going to the next page. It says determine whether the triangles are similar. If so, write a similarity statement. Okay. So this is basically this right here. And you're gonna show your work. So first of all, determine whether the triangles are similar. You're gonna write yes or no. If so, write a similarity statement. And explaining your reason would be, you know, angle similarity, side similarity, or side angle side similarity, or maybe not possible. Okay, so look at these figures and then determine whether the triangles are similar. 6, 7, and 16. Write the similar statement for each pair of triangles. Find each measure. Okay, so you're going to go ahead and create a proportion and find KL that way. So I know that these two are similar by the angle similarity, right? So we know that angle X corresponds with angle J, and then angle Y corresponds with angle K, because they're both 51 degrees. So that means that in terms of sides, YX corresponds with KJ. Does that make sense? Because it's between, so if I look at 5, it's between the 51 and that one arc there. So it should correspond with the 4, because that 4 contains that one arc in the 51. So my scale ratio would be 4 to, sorry, not 4. So it's 5 to 4. So 5 to 4 equals, and then YZ to KL. YZ to KL. But YZ is 15, right? Because here's YZ, that's 15. And then KL is X. Then I'm going to cross multiply. I get 15 times 4. 15 times 4 is 60, which is equal to 5x. So x is 12. Right? So then to write my similarity statement, you would say triangle XYZ. So XYZ is similar to triangle. What corresponds with X, J, what corresponds with Y, K, and then lastly, angle Z corresponds with L. So L. Okay. Alright, for number 7, let's go ahead and find the measure of VS. I can see we have a triangle within a triangle. Imagine that this segment doesn't exist and we have this full triangle. And now I'm going to go ahead and introduce that segment. So now, since that segment is part of this big triangle, you actually have a smaller triangle there. So let's go ahead and redraw those triangles. Here's my bigger triangle. It's going to be QVS. It's a right angle. And then I have my smaller triangle, which is RTS. So RTS. Notice that QV is 5. And then this side here, this long side here, well, actually this is the long side, but this side here, let's just say like that, that's X. And then over here, we know that RT is 3. And then what the heck is TS? That's 12. So then, I can go ahead and create my proportion. So if I want to go ahead and find the measure of VS, which is just X, I'm going to say, okay, well, QV corresponds with RT. So it's 5 to 3. That's my scale ratio, which is equal to this to this, so x over 12. So I have 3x equals 5 times 12, which that's going to give me 60. So then, that 60 divided by 3, that's 30. No, what was that going to be? That's 20. So x is equal to 20, and then you're going to go ahead and write that similarity statement. So I have this 90-degree angle here, and I forgot to draw that 90-degree angle here because look, if the smaller triangle has a 90-degree here and a 90-degree here. So let me go ahead and draw that, and there you go. X is equal to 20. So go ahead and write your similarity statement for that one. And then I will let 16 be an exercise for you. 22, we got a word problem here. May is standing next to a statue in the park. If May is 5 feet tall, her shadow is 3 feet long, and the statue's shadow is 10 1/2 feet long. How tall is the statue? So I want to go ahead and point out that 10 1/2 is basically 10.5. Right, because 1 divided by 2 is 0.5, so that should be 10.5. So you don't need to worry about that anymore. So it's 10.5 feet long. You have the person, and then you have the statue. Let's pretend that this is the statue here. So this is May. This is the statue. And May's 5 feet tall. May's 5 feet tall, so she is 5 feet tall. And then her shadow is 3 feet long. So 3 feet long. And then we have the statue's shadow. The statue's shadow is 10.5 feet. How tall? Oh, no, that's not it. Sorry. This is the shadow. That's 10.5 feet. So how tall is the statue? So how tall is the statue? So I'm going to go ahead and let you figure that out. You're going to go ahead and create a proportion there. And then we have this. We're dealing with this person, and we have this palm tree. So Sonia is 5 feet 6 inches tall. She wants to estimate the height of the palm tree near her school. She measures her shadow and the palm tree's shadow, and then sets up the sketch shown below. So here's my sketch. Which of the following is the best estimate of the height of the palm tree? Okay, so we know that this person is 5 feet 6 inches, and then her shadow is 2 feet. And then we look at the palm tree. The shadow of the palm tree is 10 feet long. How long is, or how tall is the palm tree? But the problem here is, okay, so since her height, or I should say, notice that everything here is in feet except this 6 inches. I have to convert the inches into feet. So I have 5 feet, and then I have that 6 inches. Well, if I want to convert inches to feet, I'm going to take that 6, and then I'm going to divide that by 12. Okay? Oops. So then I do 6 divided by 12, and then that's going to give me 1/2. So now I have 1/2 feet. So I have 5.5 feet. So now it's converted from inches to feet, so it's 5.5 feet now. Okay? So then go ahead and create your proportion and solve for x for that one as well. Okay?